Greetings, my name is Kiana Estrada and these are my colleagues Roberto and Lauri. Emmanuel is also our colleague but he couldn't make it to ISDC this year. We are BANA Space Settlement 5.0. What does BANA mean? Well, BANA means Great Place or Grand Place in the Puerto Rican language Taino. The number 5.0 is because our BANA is the fifth generation of BANA space settlements that were developed at the Arecibo Observatory Space Academy by other students. This version is seeking to use current and future technologies, this time with something new, which is an asteroid and moon mining export industry. Our main goal is to give humanity an opportunity to a better lifestyle. For this to be a success, BANA considers a lot the fundamental human needs, which are air, gravity, in this case artificial gravity, atmosphere, food, water, exercise, organization, and health and hygiene. BANA is divided in three main sections, which are engineering, life support, and government.
For the engineering section, we start off with the outer design of the space settlement. As you can see, it is composed mainly of a central cylinder or hub, and it is surrounded by two tori. The inner torus is the industrial and research torus, and it has an outer radius of 100 meters and is 30 meters wide. This torus will serve as a place for scientific research and as headquarters for BANA's industry called Asteroid and Moon Materials Exports, or AME, which is related with asteroid and moon mining. The outermost and bigger torus is the residential torus, and it has a diameter of 400 meters, being the largest component of the settlement. This torus will serve as the infrastructure of the settlement. On top of the cylinder, we have a dome-like structure for zero-G recreational purposes, and below that we have the docking station. The whole settlement is around 220 meters tall. For the interior design, here we have a drawing made by my brother Joel Rodriguez showing a representation of the interior design of the residential torus of the settlement. Next to it, we have the distribution of residential and agricultural areas. The citizens living in BANA will live in two-story houses with an area approximately of 196 meters squared. Here is the first floor of the houses. And here is the second floor. For the location of the space settlement, we divided it in two phases. First, during its construction and tests, BANA 5.0 will be located at Equatorial Low Earth Orbit, or ELEO, at 500 kilometers above the surface of the Earth. After the construction is finished, BANA 5.0 will be moved to its permanent location at Lagrange Point 5 due to its stability and proximity to the Moon. To create artificial gravity, the two tori will be rotating at approximately 2.11 revolutions per minute. The inner and smaller torus will be half the gravity, but it will still be comfortable for doing scientific research. We use the following equations for the calculations. Our settlement will use Hall effect thrusters as a propulsion mechanism to move from equatorial low Earth orbit to Lagrange point 5 and to keep the whole settlement in its desired orbit.
BANA 5.0's building and assembly timeline. From 2016 to 2017, the theoretical creation and development of BANA 5.0 took place. In 2018, BANA 5.0 will held its first press conference. In 2019, it will have its budget funding. In 2025, BANA 5.0 will begin its construction, which is phase 1. In 2028, the first crew members will be selected. In 2030, the crew members will begin training. In 2031, payload and the first workers will arrive to BANA 5.0. In 2035, the first crew members will arrive to BANA 5.0. In 2036, the testing phase will begin and the construction phase will end. In 2038, scientific researches initiate. In 2040, the first live broadcast from BANA 5.0 will take place. In 2042, BANA 5.0 will move from Elio to Lagrange point 5, initiating Phase 2. In 2045, BANA 5.0 will have its second press conference. In 2047, the AME industry will initiate. In 2048, the touristic phase and expansion will initiate. And in 2050, the first tourists will arrive to BANA 5.0. Now, life support. Three fundamental human needs are water, air, and food, as previously mentioned. So, how are we going to provide that in space? Well, let's start with water. For water supply and revitalization, we will be using the water recovery system, the WRS, which is divided into two assemblies, the urine processor assembly, UPA, and the water processor assembly, WPA. This system is being currently used in the International Space Station, or ISS. The UPA will collect the citizens' and tourists' urine and filtrate it in a reduced pressure vacuum distillation filtration, which will extract the water from the urine. This water will be merged with other wastewaters from the settlement and sent them to the WPA. Here, the water will be purified. Another system that will be used is the Saboteur system, or SAS, which is also being used in the International Space Station. This system uses the hydrogen and carbon dioxide of other systems that I'll explain in the next slide and merges them through an exothermic reaction, which is a reaction that releases heat. This reaction produces water and methane, but methane will not go to waste because it will be used as a fuel in the other system, the Vertical Oxidative Reactor Technology Experiment, or VORTEX. This system is being currently developed in NASA. It burns organic waste and turns it into water. For air supply and recycling, we decided to design an atmosphere similar to Earth, 78% nitrogen, 21% oxygen, and 1% trace gases. That is to give citizens and tourists a comfortable environment free from fire hazards. Here we'll be using the Oxygen Generation System, or OGS, that is composed of the Oxygen Generation Assembly, or OGA, and supported by the Russian Electro System. In this system, an electric current passes through the water and separates it into its two components, hydrogen and oxygen. Like mentioned before, the hydrogen will go to the Sabatier system and the oxygen to the atmosphere. Agricultural sectors will be producing oxygen to the settlement and reducing the levels of carbon dioxide. The Carbon Dioxide Removal Assembly, or CDRA, which is also being used in the ISS, will remove any excess carbon dioxide in the atmosphere and also provide carbon dioxide to the Sabatier system. And nitrogen for the atmosphere will be provided by nitrogen tanks. For food production, we will have agricultural greenhouses, which have 3 different cultivation methods, one of which is soy. Here, the crops will be planted into the soil and fertilized with urine-derived fertilizers, excrement compost, and ashes from the organic waste that will be burnt in the vortex device. In the hydroponics, the roots from the plants will be constantly in waters with mineral solutions. And in the aeroponics, the plants will be in an aerial, semi-closed environment where they will be spreading the roots with an aqueous mineral solution. Now I will leave you with Kiana Estrada to explain social structure and norms.
Social structures and norm ACA government. BANA will have a max population of 1,000 inhabitants from ages 18 to 55 in the first years of BANA space settlement. This is one of the pre-requirements since we won't risk a student's life in a rocket ship. We will also accept any race, but they must know English as a primary and official language. The secondary can be their native language. In conclusion, BANA is seeking for a new possibility in humankind to grow and preserve the human race. We are the next generation of space exploration, and we will ensure the beginning of a new era that we were waiting for ages. And for that, you need BANA, the new lifestyle, and the beginning of our future.